Hello everyone, welcome back to Let's Crack JEE in English, the channel of Unacademy. And I'm Jeetendra Dixit as my profile. So before we begin, let me just check the voice. All right. So today we are going to start circles, and before we begin, let me tell you about Good Evening Raghav. Before we begin, let me tell you about the Unacademy Subscription. So as you know, Unacademy is India's largest online learning platform. And if you are preparing for IIT-JEE, then you can have two types of subscriptions. One is Plus subscription, and there is Iconic subscription. So in Plus subscription, you get access to daily live classes of all the educators who are teaching for IIT-JEE, and you can follow educators of your choice. These live sessions are very interactive. You can ask your doubts during the sessions also through chat, and you can participate in polls. So sessions are interactive and courses are well structured. You can see the schedule of all the upcoming sessions in well advance. Live tests and quizzes are also accessible to you. These are the subscription charges. You can subscribe for 1 month. Hello, Gia. Good evening. 1 month, 3 months, 6 months, 12, 24 months. Right? And you'll get 10% discount in all the subscriptions using the code. You can use my referral code JEET1 and you'll get instant 10% discount. All right. Next is Iconic subscription. In Iconic subscription, you get all the benefits of Plus, and apart from that, you get a personal coach who will guide you throughout your preparation for top exams like IIT-JEE and JEE Advanced Main. Your test analysis will be done in a personalized manner. Your study planner will be given to you. All right. So these are the benefits of Iconic subscription. And in Iconic subscription charges are for, you can subscribe for 6 months, 12 months, and 24 months. 1 minute. And these are the prices: 38,000, 65,000, and 1 lakh respectively for 6, 12, and 24 months. And you'll get 10% discount also using the same referral code JEET1 you can use. Now you can download Unacademy's learning app from Play Store, and after downloading it, you can start your preparation. Hello Bhavesh, your NTSC is done. How was it? If you can finish, coordinate before December, then of course, then coordinate calculus you have just finished, right? So it should not take much time for the revision. All right, so let's begin circle. So I'm starting from basics, okay? So a point is moving First, let's do standard circle, or maybe a general circle. A point is P is a moving point, and it is moving such that its distance from a fixed point, say this is x1 y1, okay, this is fixed point. So distance of P from a fixed point O is always constant, and that constant is say R or A, whatever you want to take. Okay, you did binomial GP, theory of equations and complex numbers. Very good. Then locus of P is a circle, right? And let's write the equation of locus. So if we write the equation of locus, we can apply this condition that PO is a constant. So PO is equal to R. And what is this distance formula if you apply? So get the equation of locus of P, which is a circle. We know that it's a circle. Then it is x minus x1 square plus y minus y1 square is equal to R, right? And in this way, you'll get this x minus x1 square plus y minus y1 square is equal to R square, all right? So this is equation of circle with center x1 y1 and radius R. Radius is equal to R, all right? Is this point okay? If center is 0, 0 and radius R, then equation is x square plus y square is equal to R square, all right? And this is called a standard circle. When center is at origin, then it is called a standard circle. This is general circle, okay? So the difference is that now you can relate it with shifting also. See, this is the circle whose center is at origin, this first one, and the second one is a circle which is shifted at, see, you can see now this circle, that's number one, this number one circle is shifted at x1 y1, okay? So now its equation has become x minus x1 whole square and y minus y1 whole square, okay? So you can relate it with shifting also. You have shifted the curve, you have shifted the circle. So its new equation is x minus x1 whole square and y minus y1 whole square is equal to R square, alright? How was your NTSC exam? Kahan gaya Bhavesh? Level is medium, okay. Alright, see how to write the general equation. If I expand this, x minus x1 square plus y minus y1 square is equal to R square, then it becomes x square plus y square minus 2x1x minus 2y1y minus 2y1y plus x1 square plus y1 square minus R square is equal to 0. So in this equation, if I replace minus x1 by g and minus y1 by f and this whole thing x1 square plus y1 square minus R square by c, okay? Then I can read this equation as x square plus y square plus 2gx plus 2fy plus c is equal to 0, okay? So this is the another way of writing this equation. In general form we call it x square plus y square plus 2gx plus 2fy plus c. This is also general form, but it is written in perfect square, in terms of perfect squares, in which you can see the centers are x1 y1. But if you expand it, then equation looks like this, and you can see its center, see x1 is minus g and y1 is minus f, because center was x1 y1, so center will be in terms of g and f, it will be minus g and minus f. And also radius, if you put minus g and minus f in places of x1 and y1, it will become g square plus f square minus R square is equal to c, and you'll get R square is equal to g square plus f square minus c. So you'll get the radius is equal to under root of g square plus f square minus c. So for circle of real radius, g square plus f square minus c should be more than or equal to 0. If he further adds that circle should be of real radius and non-zero, then you'll put g square plus f square minus c is more than 0, okay? Because equality will give you point circle of radius 0. So I hope these points are clear. You got the equation, right? General equation. Now quickly let's write some few things. Intercepts. So intercept. Okay. Let me, Raghav, are you there? I'll ask few questions related to geometry of a circle. Okay. Before further learn, before further, I mean, theory of coordinate. Let's discuss some points related to geometry. Okay. So can you guys tell me that if two circles are touching each other, this point is very basic. I know that you guys know it, but I'm just mentioning it. If two circles touch each other externally, right, the distance between their centers is C1, C2. This is C1, C2 is representing the distance between the centers, that is equal to R1 plus R2, right? You know that? Is that okay? This is the first point, okay? Second point. And let me also further add that centers and point of contact are collinear, okay? This was very basic point. If two circles touch each other internally, if two circles touch each other internally, then distance between their centers C1, C2 is equal to R1 minus R2 mod. All right. Now one more point. Power of a point. Power of a point with respect to a circle. So what is power of point? Do you know? Geometrically. Say this is the point P outside the circle and O is center. Then PO, power of point P is written as PO square minus R square. This is called power of point. Okay. Distance, center से जो distance है square of that minus radius square. Okay. Radius is R. That is called power of point. And power of point is basically equal to, you can see, if I draw any secant line which cuts the circle at 2 points A and B, then this PA into PB is equal to power of point if point is outside, okay, is also equal to PC into PD. If I draw this line C and D is equal to PC into PD is equal to, if I keep drawing these secant lines, then one of the line will become tangent and say this line is T, then this will be equal to PT square, and this is equal to power of point. Okay, power of point, and I'm putting mod because when P is inside, then power of point becomes negative because R will be more than PO, right? So mod of P, this value will always be equal to PA into PB will be constant, right? So this value will always be equal to mod of power of point P. Hello Samarjit. You guys got it? Power of point. Okay, I'll explain it again. See, if you have a circle, first of all, I'm writing this. Okay, let me start like this. Forget about power of point. Okay, forget about power of point. That is just a point to. I mean, if they ask about it, then you should know. Otherwise, the main thing which we need to use is this. If I take a point outside, then do you know that the secant line which cuts the circle at 2 points A and B, and A1 B1, let's take A1 B1, this is A2 B2, A3 B3, A4 B4, and so on. Keep drawing these lines, and this is the tangent PT. This is A2 B2, A3 B3, A4 B4. All right, so this was the point which we need to remember. PA1 into PB1 is equal to PA2 into PB2, and so on is equal to PT square. Now tell me, is this point clear, Gia? Do you know this point? This is very useful. We'll use this point in the circle in coordinate geometry. Thank you, Mukul. Thank you, Samarjit. Why do you have so many names? Mayuk Roy. Jia, tell me, is this point okay? It has a simple proof also. If you want proof, I'll prove it. But let's focus on the result first. By taking similar triangles, you can prove it easily. If point is inside P, then line will be like this, a chord, right, passing through. So any chord passing through these points will also follow the same relation. So this is P, this is A1 B1, this is A2 B2, and this is A3 B3. All right. So this is PA1 into PA2 is equal to PB1, sorry. PA2 into PB2 is equal to PA3 into PB3. Okay, so that is the point for the, this is also valid for a point inside the circle. Okay. Yeah. Yes. This was a property in class 10. Now what I was adding to this property is power of point P. These values are basically equal to these values which are written here in the first equation. These values are equal to PO square minus R square. Say this is the point O, center of the circle, है ना? So one of the line which is passing through center, that will also follow this result. Say that is the line. So this is O, PA into PB. So this PA into PB, I'll prove it here. PA into PB can be written as PA can be written as PO minus R, and PB can be written as PO plus R, right? So it's very simple. PO square minus R square, right? So these values are basically equal to PO square minus R square, and this PO square minus R square is called power of point. This is what I was adding to this, power of point P. PO square minus R square is called power of point P. Now is it okay? Yeah. But in this case, PO square minus this is also equal to, but in this case it is going to be R square minus PO square, because you can see these values are positive values, right? PO square minus R square will be negative. If you take a line which pass through center, say center is here, okay, and you do the same thing which I have done in this equation. So same thing you can do here also. This is point O, right? But if you apply PO, then in this case you need to write R minus PO and R plus PO. So it will be R square minus PO square. But the definition of power of point is PO square minus R square. So power of point P is positive if P is outside, power of point P is negative if P is inside. Okay, and power of point P is 0 if P is on the circle. Is that okay? Now are you understanding this term, power of point? So power of point is nothing but distance of that point from origin, square of that minus r square. So obviously it will be positive when point is outside, it will be negative when point is inside, and it will be 0 when point is on the circle. Right? So these values are equal to r square, which can be written as mod of power of point, okay, or minus of power of point P in this case. In this case, when point is inside, because these values are positive, power of point magnitude wise is equal to these values, but it is power of point is negative, so I'm putting mod. Okay, and I'll tell you this power of point later also. It is actually S1. S1 is the point, the coordinates of, in terms of coordinates, it is S1. If you know the equation of circle, if you know the points, coordinates of the point, then just put the coordinates of that point in the equation of circle, and the value you get is basically power of point. So I'll explain that later. S1 thing. Just understand the geometry, okay? Is this okay? Then next geometrical point is this. If you have two circles, see this. If you have two circles, then what is this? This is called direct common tangent, right? Do you know this? PQ is direct common tangent. Direct common tangent. And what is the length of PQ, by the way? This is radius R1, this is radius R2. This is center C1, this is center C2. Can you guys tell me the formula? So the formula is PQ, length of direct common tangent. Okay, this is also there in class 10th. So PQ is equal to under root of C1 C2, distance between centers square, minus R1 minus R2 square. All right. So it's a simple. It has a simple proof. Just draw this line which is parallel to C1 C2. Okay. So you can see this is a parallelogram now. This is a parallelogram because you have drawn up these C2Q and C1P were already parallel because these are 90 degree perpendicular to PQ. So it's a parallelogram. So this distance is C1 C2 and this is also C1 C2 now. This distance, right? And you can see this is a right angle triangle PQ. Let's say this point is R, okay? And this distance is what? This is R2 minus R1. So you can apply Pythagoras in this triangle. PQR. Apply Pythagoras and diameter of this is PR, right? So this distance PQ is going to be C1 C2 square minus R1 minus R2 the whole square. All right. Good evening, Shubhashri. Got it? Clear, everyone? All right. And what is the length of transverse common tangent? If you draw two circles, okay, if you draw two circles which are non-intersecting and one is completely outside the other, then you get one other tangent of this type, cross type. This is called transverse common tangent, right? That was called direct common tangent. This is called transverse common tangent. Okay. So in this type of circles, you have four tangents, two direct common tangents which are of equal length. Same. This is P dash Q dash. PQ is equal to P dash Q dash, and two transverse common tangent. Say this is AB, okay? So you need to write length of transverse common tangent AB. So that is equal to, can you guys tell me the formula? Anyone? Tell me fast. Yeah, very good. So C1, C2. Again, you will make the same triangle, just extend it, and parallel, I mean, pitch this side, and draw a line parallel to, from C2, draw a line parallel to, wait a minute. Okay, basically, wait a minute. Not this one. Extend this side, okay? Extend this. Why? Because you need to make a parallel line to C1, C2, parallel to C1, C2. So draw from this A. From A, draw a parallel line parallel to C1, C2. It will meet this BC2 at point C, okay? So BC is because this is R1, right? So this is also R1. So now this BC is basically R1 plus R2, okay? Now you can see this triangle, ABC, triangle ABC, it's a right angle triangle, right? So it is, this is C1, C2. Clear? Sabko clear? C1, C2 whole square minus, now this BC is R1 plus R2. So R1 plus R2, okay? And of course, transverse common tangent is more than direct common tangent, okay? Yeah, ABC is right angle triangle. Jia, are you understanding these things? Samarjeet, are you there? All right. So, do you know this special case of direct common tangents? So this was the formula for direct common tangent. Okay. And when circles touch each other externally, then this length of direct common tangent, obviously there will be only direct common tangent, transverse common tangent will not be there. It will be one internal tangent, this, which is of zero length. Okay, so now in this case PQ is basically, now you know, C1 C2 square, this was the formula, C1 C2 square minus R1 minus R2 the whole square. But we know that in this case C1 C2 is nothing but R1 plus R2, right? This is R1, this is R2. So you can put C1 C2 is equal to R1 plus R2 the whole square minus R1 minus R2 the whole square, and this is going to be 2 R1 square R2 square will get cancelled. If you open it, it is R1 square plus R2 square plus 2 R1 R2 minus R1 square plus R2 square minus 2 R1 R2. So R1 square R2 square will get cancelled and you'll get 4 R1 R2. So 2 you can take outside and it is 2 R1 R2. Okay, so this is the formula of length of common tangent when circles touch each other externally. All right. Is this okay? Now I have a very good question based on this. Confirm fast. Okay. I have a very good question. This was there in JEE main also, but it's a very famous question. You can see this question everywhere. In KVBY also they have asked question based on this in many exams basically. So 3 circles touch each other externally and they also touch a line L. So this is one of the circle. This is another circle of radius R2. Okay. And there's a third circle which touches these 2 circles and the line. If radius of this circle is R1, radius of this circle is R2 and radius of this circle is R, Then find R in terms of R1 and R2. I'm giving you the options, okay? A is R is equal to R1 plus R2 upon R1 R2. B is R is equal to R1 R2 upon R1 plus R2. C is root R1 is equal to root R1 R2 upon under root of R1 plus under root of R2. And D is root R1 is equal to 2 root R1 R2 upon root R1 plus root R2. These are the options. D. Yeah, C is the right answer. We know we can write just the previous formula we have used. AB can be written as 2 root this is R and this is R1 and this is R2. So 2 root AB is common tangent of this is circle C1, this is circle C2 and this is circle C3. Okay. So AB is common tangent of C1, C3. So that should be equal to 2 root R1R. Okay. Similarly, BC is common tangent to R2, R3, C2, C3. So that should be 2 root R2R. And if you write AC, then AC is basically 2 root R1, R2. Is that okay? And now you can apply AC is equal to AB plus BC, right? So if you apply that, then you'll get 2 root R1R plus 2 root R2R is equal to 2 root R1, R2. And you can see this 2 will get cancelled, and then root of R is common, and it is going to be root of R1 plus root of R2 is equal to root of R1 R2, and now you'll get root of R is equal to root of R1 R2 upon root of R1 plus root of R2. In fact, you can also write this result as 1 upon root R is equal to 1 upon root R1 plus 1 upon root R2. So this year only there was a question based on this in JEE main January wale exam mein, in January exam directly. Okay, got it? Why? Oh, I'm sorry. I wrongly written R1. This was R actually, you know. We were finding R, left hand side it is R. Actually, technically, none of the options were correct. But left hand side it was R. By mistake, I have written R1. But I don't think you have focused on that, because you have given answer D. And in D also it was written R1. C is the right answer. You got it? Shall we move on then? Is GI disconnected? All right. Chalo. Now I have a question before we move on. Now we know the equation of circle. So find the equation of a circle. Find the equation of a circle whose center is at 12,5 and which touches x square plus y square is equal to 25. All right, internally and externally both. Now this is the question which you need to do by yourself. To write the equation of a circle, let me again repeat. To write the equation of a circle, you need center. If you know center, if the center is, say, suppose 3,4 and radius is 5, then equation of circle is x minus 3 the whole square plus y minus 4 the whole square is equal to 5 square. Is that okay? I think this is clear now. So to write the equation of a circle, you need radius and center. Like to write the equation of a line, you need either 2 points or 1 point and slope. Similarly, here also you need center, coordinates of center and radius. Then you can easily write the equation of circle in this way. All right. So in this question, you can see center is already given. You need to find radius. So try this. Do it fast. हाँ, touches का मतलब yes, of course. Touches means whenever two curves touch each other, that means they have a common tangent at that point. and इसको कट करना बोलते हैं. This is called cutting each other. In this way, this is called cutting each other. You won't call this they touch each other, because at this point you clearly can see they have different tangents. This is a kind of diagram. थोड़ा और टाइम. You just tell me the radius. You're getting 64, she is getting 49. All right. That means one is getting 7, another is getting 8. Okay, so now see, this point O, this point C, and let's say this point is A, point of contact. So the radius of this circle is, let's say, capital R. Then I know that OC, the distance between centers, is equal to radius of bigger circle plus radius of this smaller circle if they touch each other externally. And then OC you can find. OC is distance between 0, 0 and 15, comma 5. So that comes out to be 13, right? Capital R you need to find plus small r is given 5. So now you can see R is very simple, 8. So I think, yeah, 64 is the right calculation. You got it now? This is one of the circle. So now you can write the equation of this circle. This circle is, say, C1. So equation of C1 is x minus, center was already given. So x minus 12 square plus y minus 5 square is equal to 8 square, right? Now you need to write the equation of another circle which touches this circle externally. So in internally. So if the two circles touch each other internally, then also centers and point of contact are collinear. So this is one of the center, this is another center, all right? And if you extend this line further, then this will be the point of contact. So the another circle is going to be like this. It will touch like this. All right, getting it now? So now you know, say this point is B. So we know that CB is the radius. So this capital R, now this is say R dash, radius of this white wala circle जो है, that is say R dash. So R dash is equal to nothing but CB, and CB you can find clearly. CB is nothing but OC plus small r. Because R1 minus R2 is distance between centers now. So distance between centers is 13 plus, 13 plus 5. So it is 18. Okay. So equation of this circle will be x minus 12 the whole square plus y minus 5 the whole square is equal to 18 square. All right. Guys, got the calculation? All right. Now let me tell you another point. Now let's move. Line and circle. Line and circle. So line and circle में portion of length of, first we are doing length of intercepted portion of a line by a circle. So let's say line is given ax plus by plus c is equal to 0. Okay, wait. So line is given lx plus my plus n is equal to 0, and circle 2 degree curves are generally related by s. So circle I am representing by s. So circle, equation of circle is x square plus y square. Now we should have the habit of writing the centers and radius of this general equation which I am writing, x square plus y square plus 2gx plus 2fy plus c. Although that x minus x1 square plus y minus y1 square is equal to r square is more relatable. In that we can see the center clearly, we can see the radius clearly. In this you'll have to apply the formula, you'll have to write the coordinates with comparing this coefficient of x to is 2g, then you need to find g first, and then minus of g is the x coordinate, right? But because in most of the cases you'll get equation in this form. All right, in the exam equation is generally given in this particular form, expanded form. So we should be very clear to write the centers and radius of this circle. So let's say we know center is minus g minus f, and radius is under root of g square plus f square minus c. All right, we have written these two things immediately. Now this what we need is this circle is cutting the line at 2 points. So these two are intersecting curves. We need AB, intercepted portion, or you say portion of intercept cut off by the circle on the line. Portion of intercept cut off by the circle on the line is AB. Okay, I think you're getting this point now. What are we finding? We are finding length of AB. Portion of intercept, portion of line, you can say, cut off by the circle. All right, see how to do it. We use simple geometry here. The center is minus g comma minus f. Say the center is O. We join this O with A and B. Slope, no. Slope we are not going to use. We'll use this geometry. We'll drop a perpendicular. When you drop a perpendicular from center to any chord, it bisects it. So this C is the midpoint of AB, right? So we are going to use Pythagoras in this. In triangle AOC, you can write AC is equal to under root of AC is equal to under root of OA square minus OC square, right? OA and OC you can find, and AB is equal to basically twice of AC. So we need AB. So AB is equal to twice of under root of OA square minus OC square. Okay, this is the formula which we need to use. I'll tell you how to write OA and OC. Okay, this is the formula which we need to use. So OC is nothing, OA is nothing but the radius, okay, which we know. And OC is perpendicular distance of minus G minus F from this line. And we know how to write perpendicular distance. Put this coordinate in the equation. So minus GL minus FM plus N divided by under root of L square plus M square. Is that okay? Did you get these two values, OA and OC? It's very easy to write OA and OC. Perpendicular distance of center from line is OC and OA is nothing but radius. And because we know these two, so we can write AC using Pythagoras theorem and then double it. So we'll get the intercepted portion. Okay. Got it? All right, so let's use it. Find the length of intercept cut off by x. I am giving you a circle in this form: x minus 3 the whole square plus y plus 4 the whole square is equal to 49 on the line x plus y is equal to, wait a minute. Yeah, now do it. Got it? Yeah, 90 minus 72 divided by 25. Okay, calculation might be, I mean, root. Okay, okay. Let's check the calculation then. So we know the center of the circle. What is the center of the circle? Center of the circle is 3 comma minus 4, right? Just put this is equal to 0 and this is equal to 0. You'll get the center. Okay. So x is equal to 3 and y is equal to minus 4. Now this line, let's say this line cuts the circle at A and B. This point is, let's say, O. If I join OA and drop a perpendicular, this is say C, point C. So let's write OC first. OC is distance of 3 comma minus 4. So that is 9 plus 4 into minus 4 minus 3 divided by under root of 3 square plus 5 square. So that comes out to be how much? 10 by 2 are, this is coming out to be 2. But I can see this is a very simple calculation. It's a very simple calculation. OC is 2, right? Is it, Gia? Oh, sorry, yeah, 4 square. Yeah, but that's what it is, 10 upon 5, no? So 2. Yeah, I've done 4 square. I've taken it 4 square only, wrongly written 5 square. But I consider in my calculation it is 4 only. 3 square plus 4 square is 5. So I did it using 5. Oh, what am I doing? And 5 is going on in my mind. 5. Not painful. OC is 2. Actually, I checked that calculation. And while framing the question, I was checking the calculation only. So this OC is 2 and radius, though I managed myself, it was 49. So radius, matlab OA is equal to 7. Then you can see AC is equal to under root of 7 square minus 2 square. So it's 49 minus 4. 49 minus 4 is 45. 45 is 3 root 5. Why are you getting 2 root 11? Radius is R square is 49 now. So 49 minus 9 square, 7 square minus 2 square. It is 45 Gia. So this is 3 root 5. So now AB is double of this. AB is twice of AC, right? So twice of AC means 6 root 5. 6 root 5 is the answer. 6 root 5 is the answer, okay? Now you guys got it now? You guys got the calculation? How to find the length of intercept? Alright. Quickly, I'm telling you 2 formulae and then we'll continue tomorrow. X and Y intercepts. X and Y intercepts of a circle. X intercept means, in a circle, X intercept means the portion of segment cut off by a circle on X axis. A length of segment, you can say. So this line is X axis. This AB is called X intercept. Similarly, now you understood what is y-intercept. So if circle is like this, if circle is like this, then this AB is called x-intercept and this CD is called y-intercept. So basically, segment cut off by the circle on x-axis is called x-intercept, and segment cut off by circle on y-axis is called y-intercept, length. And but it's not necessary that x-intercept and y-intercept will always exist, because it might happen that circle is not meeting the x-axis at all, right? It might happen. Circle might be this also, might be like this also. That means there's no x-intercept, no y-intercept. They will not be real. In this case, there will be x-intercept but no y-intercept, right? So let's see, first of all, let's see what is the formula of x-intercept. This point is for general circle we are writing, okay? Circle is given x square plus y square plus 2gx plus 2fy plus c is equal to 0. For this circle we are writing the x and y intercepts. So this is O, coordinates are minus g minus f. Let's take this radius r, this point is c. So now we know how to write AC. So AB is equal to twice of AC is equal to twice of. Now how to write AC? AC is OA square minus OC square. And now we know OA square is nothing but R square minus OC square is nothing but, see this OC. OC is y coordinate, mod of F, right? Because this line is now x-axis. So any point, distance of any point from x-axis is mod of its y coordinate, mod of its ordinate, right? I hope you're getting it. So this is f square. And if I put the value of r square, then if r square is nothing but g square plus f square minus c minus f square. So this f square will get cancelled. And this is 2 under root of g square minus c, alright? This is x-intercept. And now you know the meaning of x-intercept. So x-intercept AB is 2 under root of g square minus c. Similarly, we can write y-intercept. And y-intercept OC will change, okay? In y-intercept you can see this OC is going to be mod of g, right? So now g square will get cancelled. So in that it is going to be 2 under root of f square minus c, right? And g square minus c should be positive to get a real intercept. If g square minus c is equal to 0, that means circle is touching the x-axis. If g square minus c is equal to 0, that means length of intercept is 0 and circle will touch the x-axis. Are you getting that point? And if g square is less than c, that means circle is not meeting x-axis. Alright, x-axis is passing outside the circle. Guys, got it? Got these x and y intercepts of circle. We have got the length of intercept cut off by a circle on any line. These two are formulae, x and y intercept, which you can remember. Because in questions they use it, x intercept is this, y intercept is this. Then you can directly use it without wasting time. Alright. So we will continue tomorrow because I have a session, practice session of straight lines, okay? So we will begin at 9 o'clock, practice session. Alright. That's a different calculation. If you put y is equal to 0, you'll get a quadratic in x. And quadratic in x means roots of that quadratic will represent the coordinates of these points x1 comma 0 and then x2 comma 0, right? And then this AB is nothing but mod of x2 minus x1. So if you put y is equal to 0 in this equation, you will get a quadratic in x. Y is equal to 0 means you are solving this circle with x-axis, okay? And if you're solving this circle with x-axis, that means equation of x-axis is y is equal to 0. So you need to put y is equal to 0 in this. And if you put y is equal to 0, you'll get a quadratic in x. And in that quadratic, roots are x1 and x2. And x1 and x2 are nothing but the coordinates, x coordinates of points A and B. And if you get the x coordinates of points A and B, then you can write AB is equal to x2 minus x1 because they are on x-axis. So in that quadratic of x, you need to find the difference of roots. So if you apply the difference of the roots formula, you'll get this. This is what you are talking about, I think, right, Raghav? All right, chalo. Okay then. Okay, Raghav. See you tomorrow. I'll message you guys. Most probably it will be at 3 o'clock only. But if there will be any change, I'll message you, okay? Before 3 o'clock. All right, chalo.